Well, thank you all for coming today. It's great to have you all here. And my name is Ann Thrupp. I'm with the Berkeley Food Institute. And for those of you, there are many of you who are from out of town, and we want to thank you for coming to Berkeley. It doesn't feel like Berkeley right now. We sort of feel like the past 2 days have felt more like Hawaii, so hence I've got Hawaiian clothes on. But it's really a delight to have this program today in collaboration also with the Natural Resources Defense Council and Organic Valley, who are collaborators and co-sponsors. So as I said, my name is Ann Thrupp, and I'm the executive director of the Berkeley Food Institute, which is an institute here at the University of California. And we are engaged in research, education, and linking that to policy and practice. And so really we're trying to bring together, we are bringing together a diversity of people in many disciplines, as well as working with stakeholders to aim towards advancing sustainable and resilient and just and healthy food systems. So that's a lot, and a mouthful to express all that we're doing. But basically this kind of event reflects this type of collaborative approach. This is part of a series called the Food Exchange Series that we've been holding all year on a monthly basis. We usually have one panel, but we're delighted today we have two panels since there's such interest in this topic. But we select a diversity of speakers on purpose to engage in lively discussion, and I hope that that'll happen today. I'm sure it will. The idea is to be interactive, so we will have two panels today. The first will be scientists' perspectives, and the second will be practitioners' perspective. And I'm sure there's going to be some overlap in both of those, that issues will come out from both perspectives. The idea is not to separate those two, but to engage in a conversation. So I also just want to give you sort of the background, the framing of why we chose this topic. And I think all of you came here with recognition of the importance of sustainable livestock. But there's definitely growing public attention to livestock production and its implications in the United States and internationally, as we all know. And there are lots of concerns, serious concerns, about the farm animal welfare, the carbon footprint of animals, and pollution issues, health and environmental impacts, a diversity of impacts that I'm sure you're all aware of. But on the other hand, and that's why we're here today, there are an increasing number of examples and initiatives undergoing where producers and programs and scientists are working together to develop more sustainable and organic approaches in livestock management. And that is not only in beef production, of course, but also in pork, in lamb, in dairy, in a whole range of livestock initiatives. So the panelists today are going to talk about innovations and scientific findings in livestock operations in the range of different production settings, and to discuss the environmental, economic, and social outcomes. The panel is also going to include a discussion of how and why such practices can contribute to the health of ecosystems and people, and how they can be scaled up and advanced, disseminated more widely. And the panelists will also address a diversity of critical questions that our moderators will raise, and will also open up an opportunity, of course, for you to raise questions to the panelists. So with that, I just want to close by, again, welcoming you all and introducing our moderator for the first panel, Jonathan Gelbard from the Natural Resources Defense Council, and he will introduce our panelists. Thank you.
Thank you so much. When it comes to understanding what the impacts of poor management are and what the benefits of better management are, science is really the critical underpinning. What impacts are specific to some regions or soil types, which are more general? What solutions apply more generally and should be applied, and what really are appropriate for specific regions, specific soil types, or even individual ranches? Science really helps us answer these critical questions for driving progress towards the goal of a more sustainable livestock production system and systems. And today, I have three truly remarkable scientists on this panel, starting with Dr. Chuck Benbrook. He is a research professor at the Center for Sustainable Agriculture and Natural Resources at Washington State University. Dr. Cindy Daly is a professor of agriculture at California State University, Chico. And Dr. Nathan Sayre is an associate professor and chair of geography at the University of California at Berkeley. And they really have different suites of expertise, remarkable backgrounds. And the way this is going to work today is we're going to start off, each of them is going to talk a little bit about their work, their expertise and their findings. And then we're going to engage in some discussion, some questions, and finally we're going to open it up to questions. So hold your questions. There will be a question and answer period for the audience. And with that, since I got Chuck sitting right next to me, Chuck, tell us a little bit about your work.
Okay, I'm a research professor at WSU and running a program called Measure to Manage. I'm developing analytical systems to quantify the nutritional quality of food and the safety of food, and also to try to calculate the environmental footprint of different agricultural systems. For many years, I was the chief scientist of the Organic Center and had the opportunity to work with many of the great organic dairy farmers and organic dairy companies in the country, including Organic Valley, and started to pay attention to what the literature was saying about the impact of organic dairy farming on both the environment and milk quality. And as many of you know, there's been much more public investment in Europe in the impact of organic production systems, both plant-based and animal, and also both on the nutritional and public health impacts of organic food, as well as on the environmental footprint of organic operations. And there were some very enticing findings in the literature from Europe about how organic dairy production improved, for example, the fatty acid profile of organic milk. And so I found out that Organic Valley had, over an 18-month period, systematically tested samples of their organic milk on a given day at one of their processing plants, along with a sample of the conventional milk that was running through the same plants on the same day. And Organic Valley did a complete fatty acid profile of both of these samples of milk once a month in 17 processing plants over a 1.5-year period, creating the largest sort of comparative database that anyone actually in the world has had a chance to dive into, to look at the impact of organic dairy production. And you know, I put together a team to do the analysis and prepare the paper, which came out in December in PLOS One, and I think everybody was very pleasantly surprised by the significance of the differences. The key metric when you think about fatty acids in many foods, and certainly one of the key metrics in milk, is the ratio of omega-6 fatty acids to omega-3s. This omega-6 to omega-3 ratio is a very important indicator of the healthfulness of a person's diet, because in Western diets we've got way too much omega-6 and not enough omega-3. So this ratio has crept up from prehistoric time when humans, as we evolved, we had a diet with about equal amounts of omega-6s and omega-3s. Now in Western diet, it's 10-to-1 to 15-to-1, with some people having diets as high as 40 or 50-to-1. Diets with such a significant imbalance increase the risk of cardiovascular disease, diabetes, overweight, several cancers, and also are associated with a number of really serious developmental problems. If a pregnant woman is not getting enough omega-3s as her child forms, there'll be developmental deficits in the brain and the eyes that will have lifelong consequences. So we dove into this data set and found that conventional milk has an average ratio of about 5.7-to-1, which is actually, for the major food groups, it's about as good as it gets. They're in terms of a ratio. but the organic milk, with the significant commitment of most Organic Valley farmers to using pasture as fully as possible, the ratio was all the way down to 2.3 to 1, which is actually about optimal for the promotion of cardiovascular disease based on what's in the literature. And I've for the last 10 years, I've tried to read everything in the literature on the nutritional impacts and benefits of organic production systems, and I know of no impact of organic farming, either plant-based or animal, that even comes close to the significance of this shift in fatty acid profile in grass-based, pasture-based organic milk. And so in the course of doing all this research, we learned a few other things. Organic Valley and a few of the other organic dairy processors, they've got some new niche products that are 100% grass-based milk. In that milk, the ratio is about 1 to 1. It's just dramatically different. And in grass-fed beef, if there's no grain in that animal's diet, then again, the ratio in the beef fat is about 1 to 1. And then, so we looked a little deeper, and lo and behold, think about the non-plant protein in the human diet. Fish, eggs, beef, pork, lamb. All of these animals and fish have been moved progressively towards a more grain and corn-based diet because those have been cheap, subsidized, widely available feedstuffs. And the omega fatty acid profile in the meat and fat, and the fat in all of those products has shifted dramatically over the last 4 decades. And it's one of the major reasons why we have this imbalance. So there's a real encouraging awakening going on in the nutrition community about fat. The science is really rapidly changing. I think we're going to see some significant changes in the new dietary guidelines for America that are going to come out next year. So that's what I'm going to be working at, this interface of how animals are fed and the nutritional quality of the animal products that come out of those systems, and hopefully also get into some of the environmental and greenhouse gas consequences of shifting from grain-based to grass-based animal systems.
That's fascinating and an important body of work. So Cindy, how about yourself? I've seen a little bit of a remarkable grass-fed beef website at Cal State Chico. Tell us about what you're doing.
On campus, we've developed a couple of learning environments for students, because that's basically what our commitment is to education, and to try and to develop applied research program that really facilitates and supports organic farmers, in particular the organic dairy producers in to the largest extent. So we have the only organic pasture-based dairy program west of the Mississippi that's really devoted specifically to an educational model where students can get directly involved in that production paradigm. So we've got 12 students currently milking cows. They're mixing rations. They're interacting, doing grass management, intensive grazing practices. And they're also involved in our applied research program and very much involved in our industry activities. We've worked hard, to bring online an organization that's specific to support organic dairy producers, the Western Organic Dairy Producers Alliance. So in that venue, then, our students are able to interact with a lot of producers. And what we hoped is that would create a forum for producers to network more in a way that is more supportive, because up until this point, the organic producers have had very little resources to rely upon. As a matter of fact, the universities have been slow to really adopt organic programs, and organic producers have pretty much been on their own to develop their own production programs, and it's been trial and error for many of them. So we're here to try and provide some support. We're also here to educate some young people to try and get them excited about sustainable agriculture, specifically about organic production programs. So that's been a big part of what we do, and I have some full-time staff that are devoted to that on a regular basis. And I'm there as much as I possibly can. So I'm almost as much farmer as I am researcher at this point. And in addition, the applied research program has really taken on an extension flavor about it, because I have a board that makes recommendations in terms of what direction we go with our limited funding. So it's the farmer who really directs our applied research program. What specifically do you need? What kinds of projects would be of most value to the organic dairy producers? And by and large, it's sustainable feeding strategies, because that's 60 to 70% of their costs are really tied up in feed. And we're in a pretty significant drought in this part of the world. It becomes even more evident that that's an important part of what's going on in the organic industry. So we've spent quite a bit of time in our applied research program dealing with that particular issue, looking specifically at ways in which to produce a more cost-effective feed. And looking specifically at forages and grasses, more effective grazing practices, looking at soil fertility, because all things come from the soil, and if we don't really address that component, we're going to have problems down the road. We're going to have problems in terms of herd health and milk production, profitability. All of those things are really balanced on high soil fertility. And frankly, the universities are training people at the universities very specifically. To be an animal scientist, you learn about nutrition, you learn about reproduction, but you know very little about forage production, you know very little about soil science or water or ecology. So this is a shift. It's a huge paradigm shift for us to be moving in those systems-based programs. And I'm seeing more programs like Washington State. There's many programs that are now picking that up and doing more systems-based work, which needs to happen, because we all know that as farmers, we're not specialists, we're totalists. We have to understand the system in order to make it work and make it function well. So the study that we embarked upon initially was looking at soil fertility and its effect on forage quality and milk production. And then ultimately, what does that do to the bottom line? If we put $289 worth of soil amendment into our soil as an investment into our soil bank account, what do we actually get in return? And we learned some amazing things. It was pretty quick that we got a return. We had 50 acres devoted to this project that we randomized to a study where we had it replicated, where we amended half and we kept the other half just status quo, as most producers would do. What we had seen is that we increased our overall forage production significantly so. So we're making more forage, we're making more grass on the same base, on the same land. And then the quality of it was significantly higher. So yeah, that was pretty, that was an eye-opener for me as well. To see that the quality of that feed went up dramatically. So we did some number crunching and we did some calculations, and we actually determined that we were making almost $485 more an acre by investing our $285 in soil amendments. So that's a pretty good return on your investment. So we've been working hard at getting that information out to producers, and granted, that's going to be very site specific. We happen to be in some soils that's a Chico loam. It's a very calcium deficient. So if you look at our base saturation for calcium, it's only 55%. And I believe that that's probably the biggest limitation in our soils, besides we've got some nitrogen deficiencies, is the fact that we're calcium deficient. And that is a huge component that lends itself to high quality forage. High quality forage is going to make more milk and higher quality milk. So that's been a component. We're also looking at other alternatives, because we know that producers who are the most profitable are those that are producing more on-farm feed. So we want to make higher quality feed, we want to make more of it, And so we're looking at fodder, which is sprouted barley, and as a replacement for grain. We're looking at low grain. We're looking at higher grass, lower grain rations as well. Looking at the economic implications. So I have a couple of ag economists that are on staff that are also helping us with those. So that's really how we focused our applied research program, and this is what we're teaching our students in our program.
Cool. Excellent. Wow. Thank you. Nathan, tell us a little bit about what you're doing here at Berkeley.
Okay. Thank you. I should start by saying that I'm a social scientist. I study people, and the people I study are people who either manage ranches, manage livestock, or people who study rangelands and livestock. So I have sort of two major areas of emphasis in my research. One is working with ranchers, working particularly with groups of ranchers in collaborative conservation efforts. I've been involved with the Malpai Borderlands group in Arizona, for example, for about 12 years now. And working with them to contend with whatever issues they're facing. Some of them are scientific issues, many of them are policy issues, issues with the Forest Service or the Fish and Wildlife Service about endangered species or fire, issues with working with the NRCS to implement conservation practices. That whole suite, and they're a group of people who have been trying to keep their lands from turning into subdivisions, trying to reintroduce fire to something closer to its evolutionary frequency. And they've made a lot of progress, but it's not something that's very quick and simple to accomplish. So that's one part of it. The other part of it is a study of the history of range science. Again, from a social scientific point of view, I have read a lot of the literature about range science, but I, again, am not actually a range scientist. I don't do controlled experiments. In contrast to the first two speakers, the lands I'm looking at are rangelands for extensive livestock production. They are not fertilized, they are not cultivated, they are not irrigated, right? They just grow whatever they grow with the rainfall that's available. The animals eat whatever that is that's palatable to them. It's not an industry that has typically been embraced as organic, but in many ways it lends itself to that type of approach. There are not a lot of chemical synthetic inputs involved, or at least in theory you could get by without hardly any of them. It's also a field in which there's a strange disconnect, I think, between the range science community, the academics who study these questions, and the practitioners, the actual ranchers. It's not really a disconnect by intention, but it is, to some degree, a disconnect by design. Huge controversy between scientists and a lot of ranchers about Alan Savory's holistic management and rotational high-intensity grazing, for example. The ranchers swear by it. Many of them do. You can go visit their ranches. It's hard not to be impressed. The scientists have done lots of experiments, and virtually every one of them has said, this doesn't work. It's a puzzling situation. I have a theory about how you might reconcile those points of view, but without getting into it, I think it just is indicative of the fact that the science and the art of range management are not simple to reconcile. And I think there isn't a single recipe for how to manage rangelands correctly or best. The science can answer very discrete questions with controlled experiments and replication and so forth. But the bigger picture is one that requires other kinds of approaches, I think, to really understand. And the ranchers that I work with, many of them have been ranching on those same pieces of land for such a long time. They really know that piece of land, and what they know may in fact be the best possible information, even if it's not verifiable by controlled experiment. So some general principles that emerge out of both the historical work I've done and also the on-the-ground work. The importance of flexibility in management is enormous. The variability and the site specificity, variability both in space and time of forage production is so extreme. Being able to rapidly adapt your management to those changes and getting away from the idea that there's a correct fixed number of cattle you should have on a piece of land. Getting away from the idea that there is a utilization rate that is the correct one, that everyone should practice every year. The idea that you should try to use all of your forage evenly across the entire ranch. These are old ideas. They have histories that help explain why we got to them, but they are kind of going by the wayside with growing recognition of the need for greater flexibility. The need for planning and management at finer grains and larger extents. The need to get ever more precise in the way you look at your land and the way you understand that land because of the variability, even as you also situate it in much larger spatial and temporal frames. In other words, you need to think about the big landscape, but also have precision, greater and greater precision. Animal unit months is simply too coarse. You need to be thinking about animal days per acre, which is a smaller temporal unit. Fencing and rotation and lots of small pastures can help you achieve greater precision and greater control at these finer scales. It's not the only way that you can achieve that, but it's one way of achieving it. And I think that's a big part of what Savory's contribution has been, is helping people see land more fine resolution and manage with more control at those fine resolutions. The importance of heterogeneity and multiple disturbances, thinking about livestock grazing as a disturbance, but also thinking about fire and drought and frost and other kinds of disturbances and how they have interacted with each other to create heterogeneity in both space and time, and to try to manage with that instead of striving for this kind of uniformity, which really was the recommended practice. That was what the Forest Service and the scientists told us to do for decades, but it doesn't look anymore like that's the proper way to do it. Quickly, some cautionary points that I think are rooted in the scientific literature, that rotational grazing in and of itself is not the answer. It may be part of the answer, but it's not the rotation per se. I think there's something else, that it helps, but it's the something else that's actually more important. Carbon sequestration on rangelands is not likely to be the answer either. We can get into that more later on. Everything I've said applies more strongly the drier the landscape you're dealing with. If you're dealing with more than 20 inches a year average rainfall, much of what I've just said perhaps is not that important. Most of those lands have been converted to other uses in this country. Most of what remains as rangeland is drier than that, and the drier it is, the more important these issues of flexibility and heterogeneity and so forth, and the more limited the carbon sequestration possibilities. Since I'm a social scientist, I'm as interested in the social factors as the biophysical ones, and some major factors inhibiting the application of these kinds of principles by more ranchers. The first one is debt. It's the 800-pound gorilla in most discussions, I think. It's not something people like to talk about. It's hard to find out exactly how much of a problem it is. But ranchers with debt, in my experience, have got a lot less freedom to maneuver and innovate and be creative and be flexible. And it's a big issue. Policy, there are entrenched in the Forest Service and the BLM, there are legacies of policies from decades back that also inhibit it. And then finally, the larger economy, the price of land, the domination of the livestock sector by processors and feedlots, the concentration of the meat industry. The interesting thing about rangelands, they're huge, right? They make up like 40% of all the land on Earth. In this country, they contribute a pretty small fraction of the overall feed that goes into our livestock. And all of the growth is in the industrialized, grain-fed livestock feeding operations. That is something that ranchers are just in a very difficult position trying to compete with. And the subsidies that support that system are effectively hurting ranchers.
All right, thank you very much. So we've talked about rangeland ecosystems and policy issues, and we've talked about educational tools for advancing the solutions and giving ranchers and farmers the resources they need to implement these better practices. And we've talked about the nutritional benefits, these remarkable nutritional benefits better practices. And to start, I'd like to ask you, Cindy, can you talk a little bit about some research that demonstrates connections between the health of farm and ranch ecosystems, the soils and vegetations, even water quality, biodiversity, pollinators, for example, and how that reflects on animal health as well as the health of the operation, its profitability, and if possible, provide some examples in which the benefits of best practices outweigh the costs and have really shown to be these classic win-win, profitable and beneficial for animals and ecosystems types of solutions.
That's great. You gave me the softball one right away. I appreciate that very much. Yeah, well, we basically see, the organic system as a system that represents what you're discussing there. There is more biodiversity on an organic farm by definition, because that's exactly what we're looking for on an organic system is that biodiversity. We want biodiversity in the soil as much as on the soil, and that's going to be an essential component in terms of trying to create this inertia, this energy, this system that feeds forward in a true organic system. I mean, that's where we're at. And that's what's lacking in the conventional world, is that we have too many withdrawals from the soil bank account. And so with an organic system, it takes almost 5 years. I think Iowa State said that was roughly what it took in order to replenish soils in that region. But that's going to be very region specific in terms of just what it takes in order to feed that soil to get it back to a condition where it can feed forward. So we're trying to build soil diversity and trying to create as much biology in the soil as possible, because that's really what's feeding our plants. It's that soil biology, that ecology in the soil, the livestock in the soil that's really feeding our plants. We want to create as much diversity there as possible. Now, one way to do that is to put as much plant diversity on top as possible, because that lends itself to creating more habitat for a more diverse microbial ecosystem under the soil. So it works, it's a symbiotic relationship. So we need to create that in order to get it to move forward. So once we do have that, then we have nutrient-dense forages, and that's what we were trying to create. We knew that our soils were very deficient in calcium. So we had to do some things in order to bring that up. Now, you don't do that overnight, because soil is a very big matrix, right? So, we did it gradually, and, we by compost, which is a soil probiotic. You're basically inoculating your soil with a probiotic with compost, a really good compost. There's compost and then there's compost. So you have to be very careful about what you're talking about. And then we used gypsum because it was inexpensive, a source of calcium that was organically certified, that we could move ahead with. And it was, not only had calcium, but it also had sulfur, and it demineralized slowly. And we're looking for that. So that's what we had used in our system, and it was something I could afford, because I have to live within a budget. I'm responsible to the taxpayers of the state of California, so I'm very cognizant of that fact. So we worked, it took us 5 years really to get to that place where we've got our base saturations up around 63. We need to be at 72, but we're making progress towards that end. And now that's not just all the external things that we're throwing at the soil. Now we're getting the biology to help us with that process of building soil organic matter. So we're getting that engine to start to hum, and that's what we want to do. We want that diversity to start humming, and when that happens, then we start building more diversity on top. We've got more nutrient-dense plants, and that's where we're getting healthier livestock. And the more the more full nutrition we're able to give those cows, because those plants are going to be higher in vitamin E and vitamin A. We're more carotenoids, more omega-3. We're seeing that in the milk, as Chuck's research clearly shows. It's also coming through in the cow, and we're seeing a lot, much improved herd health in our organic herds because of that. So the higher the forage intake, the higher the health. And that's pretty consistent with the European data and with some US data, which is kind of an interesting interpretation in some of the Journal of Dairy Science that I recently saw, but we won't go there. But ultimately, I guess my point is this, is that the diversity lends itself to providing the breadth of nutrition that we need in the dairy cow or in the beef cow. And that provides the nutrition in the final product. The only reason why we've got higher omega-3 and a much improved 6-to-3 ratio is because we put that into the cow through her grass. And the higher the nutrition in the grass, the higher the nutrient-dense food that we put on the table. It's a continuum, and it's a continuum. And so any break in the link in that chain is going to create some problems with respect to herd health or with the nutrition in the final product. Did I answer your question?
You did somewhat, and it actually brought up me thinking about, we talk a lot about the benefits of organic practices versus conventional practices, not only for the health of the animals, but for the health of the products themselves for people. And that's what's going to really help drive this and get consumers interested who are interested in improving their health, the health of their children. And we also talk about the health benefits of grass-fed versus feedlot-fed beef. But the impacts of these different types of practices of better management in general, I have to wonder, and this is for you, Chuck, have there been any studies that have looked just within grass-fed or within organic at the effects of better grazing management, for example? Do we see on ranches that have good grazing management that sustains healthier soils, do we see actually healthier meat or milk products compared to overgrazed ranches where the soils are eroding and have been depleted of nutrients?
Well, and Nathan should weigh in on this too. Sure, for grass-based dairy operators, those that do a better job managing their soils and their pastures, they're going to get both more feed production out and it's going to be a higher quality feed. One of the things is, for this huge chunk of the land base that's pasture and range, for most of the last century in North America, it's been unmanaged for all intents and purposes. And look at alfalfa. An alfalfa production system is highly managed and has benefited from genetics and all of the other new technologies that have been brought to bear. And heck, there's ranchers in California that are harvesting 6 or 7 tons an acre, right, of alfalfa. Well, the same can be done on a pasture and rangeland within the constraints of the natural rainfall. As Nathan said, if you're only getting 5 or 6 inches of rain, you're not going to be able to do too much with it, and it becomes even more important how you manage in a temporal way both the growth of the forage on the range and how the animals take it. If you're in the coast, like along the coast of California or Oregon or Washington or in New Zealand where it rains all the time, you can do many different things with pasture-based systems that because you've got that rainfall. But I think that what encourages me is people are beginning to understand what high production systems that push animals and push crops to maximize yield, milk production per day, pounds of strawberries per acre, bushels of corn per acre. American agriculture, conventional agriculture has doubled, tripled, and in some cases increased 4-fold average yields in the last 50 years. But as a result, the nutritional quality of the food has been actually rather dramatically undermined. And the changes in the nutrient profile in a lot of our crops are in fact what's behind some of our major public health problems. And this awakening is happening, and I think it's really going to help drive change in some of our ag systems.
It's an exciting time as we explore the benefits of practices that are better ecologically and how they enhance health as well. Nathan, do you have anything to add on benefits of good grazing management as far as meat or milk quality?
I'm not aware of any studies that go to the specific question that you asked, right? Sort of within grain-fed or grass-finished, within organic, within, does the quality of the management affect the quality of the food? Has that been measured? I think it reflective of the larger point that I alluded to at the beginning, that a lot of the most interesting experimentation on rangelands is actually being done by ranchers without scientists participating, without scientists collecting the kind of data that would be needed to turn it into a peer-reviewed paper. Not because it couldn't happen, but because it would be very difficult and very expensive, and in many cases, what the rancher needs to do to manage the operation violates the sort of underlying protocols of scientific experiments, right? It's about changing your protocol all the time. You need a 5 or 10 year study to get to work through the variability, but in that 10 years, the rancher can't just follow a predetermined, fixed management strategy on this piece and then not on that piece. I mean, you have to be flexible, and that means by the time you're done, you will have confounded your experiment, right? Moreover, there are good studies about the presence of birds and other kinds of native wildlife or plants, the diversity of them on managed grazed land versus land that's been turned into subdivisions with lots of space in between the houses. There's even lands that are no longer grazed and they don't have houses, but the diversity of birds goes down. When it gets to the actual quality of the meat itself, the Malpai group attempted to do this, right? They attempted to try to find out what the quality of their animals was from that kind of nutritional point of view. But by the time those animals actually get to slaughter, they've moved through so many people's hands. And so you can, if you work really hard and you get an agreeable slaughterhouse, they'll actually allow you to keep track of your meat through the process. But if you're only sending 20 or 50 cows through a plant that manages, that slaughters thousands a day, what they found at the end was, okay, yeah, it grades pretty well, but not so much differently from other meat that we'd be able to make a premium price out of it. And I think that's reflective of the fact that even before it gets to slaughter, somebody else is going to have to feed it out. And that gets to Chuck's point. These are areas that get 12 or 14 inches of rain. Much of the year, the grass is not green. You don't really want to take an animal off of grass that's not green and slaughter it. So it would be nice, but I wouldn't myself count on the scientists coming up with a peer-reviewed paper to answer your question anytime soon.
Very interesting. It just goes to show what we're up against as far as not only creating more sustainable supply chains, but marketing them and their benefits. And speaking of organic and conventional, grass-fed versus regular, have you noticed whether grass-fed or organic ranches tend to be in better ecological condition by any environmental metrics compared to conventionally managed operations?
And we were just talking about that last night, that there was a young man that came to one of the tables that we were at after the award ceremony, and he was talking about metrics and how important it would be in order to do something that could objectively monitor that within the different systems. And currently, I'm not aware of anything other than, our basic soil organic matter levels would be a good indicator of, just your farming practices and what kind of a farmer you are. We're using some, basic barometers like, earthworm inventory. Just how many earthworms do you have per cubic foot is another indicator of just what kind of a farmer you are. And that's, those are, pretty basic, pretty simple. But I think what he was actually thinking about was, looking at other kinds of ecological parameters that could be monitored, could be quantified and then monitored over time to show the change. But I'm not aware of, currently of anything that's been published specifically that shows, the ecological change, other than, some of the environmental studies. It does show that there's improved water quality on organic versus conventional operations. I mean, that's been shown. That we actually build soil organic matter on organic farms as compared to conventional farms, that's been shown. I mean, the Rodale Institute was here, I think I don't know if Mark is in the audience or not, but anyway, they've done a 30-year study on comparing the differences between an organic farming practice where we've institute cover crops and a rotational system, legumes, as compared to what's done conventionally, which is corn and soy, and a full tillage. And there's no comparison. I mean, they huge differences in soil organic matter and soil profile. So there's those kind of ecological components that you can monitor.
So what the unfortunate reality is we know a lot more, and there are much better metrics on some aspects of the breakdown of conventional systems, which is being researched and being watched with considerable concern by a growing cross-section of conventional farmers and food businesses. I mean, right now in the Midwest, you're not going to find a lot of earthworms in your average corn and soybean farm. You got Bt proteins in the soil that have dramatically changed, and probably one of the biggest and most important indicators is how many glyphosate-resistant weeds do you have on your cropland, and that's going to be a kind of a standard reference of how sick a weed management system is, and I think that there's, unfortunately, we just know a lot more about what's not going well in conventional agriculture than what the healing capacity and dynamics in sustainable and organic systems. It's happening out there, and it's unmistakable on a long-term, well-managed organic farm. It's unmistakable. The crops are beautiful. There's not a lot of weeds. Animals are healthy. They're very profitable, but we don't have a lot of science on them.
Right. It takes time to go there, though, because I think the transition period is a rough road, and I think there's a huge paradigm shift. There's a learning curve that's associated with going from a conventional paradigm into an organic one that I think really requires commitment on the part of the producer in order to go there. I've seen it time and time again. I mean, I come from north central Illinois. My folks are conventional farmers. The neighbor tried to go organic, and he's the talk of the coffee shop, which is really detrimental, and it was definitely a problem for him because no one likes to be the outcast in that kind of a tight-knit rural country and community. It was very difficult for him, even though he had the right idea. He was a small dairy. He wanted to stay in business as a small dairy. He'd been in the family for 5 generations. And he made it a good go, but it was a real struggle for him. And I'm 2,000 miles away and tried to feed him books, and the extension service basically laughed at him. And so it was a real struggle. So there are many farmers in that same scenario, and it takes time to go there because you have to do this first. You have to get your mind around it, and then you have to be able to implement the right practices by reading your land. Very similar to what Nathan was talking about. You have to be able to adapt to the changes that you're seeing and make and implement the correct changes at that time, and you have to keep the faith over a period of years, because it would take you 5 years in that kind of a phenomenon, in that kind of a situation, to really get that system humming again. And I keep using that word humming, but that's exactly what I mean. It's an engine that has to be charged so that it can run. And until you actually feed the engine and put all the parts together, you're not going to get that system to move.
Given the drought this year, one of the issues that we hear is the challenge for organic farmers and ranchers of finding organic feed. Is there, in the absence of the availability of organic feed, are there any other types of, whether it's certifications or practices that you'd want to look for that would sort of be the next best thing to keep that engine humming?
Well, if you're certified organic, you've got to stay with the program. I don't know whether there's going to be any kind of variances or allowances later this year in the West in the event of really a catastrophic failure in organic pasture and feed. It's possible, but I think unfortunately, the principles of organic farming would say if you don't have the water and don't have the feed, you've got to cut back on your animal numbers, or change how you manage your animals so that you can get through in a period of time where there's less feed. So you might extend your horizon for how long it's going to take to get a steer to slaughter weight. Let them grow. You accept that they're going to grow a little bit slower, and on a dairy farm, maybe you're going to lose a little bit of production per day. You're going to let that cow settle down a bit more and accept that lower income. But there's the organic farmers don't have the options and alternatives to try to supplement what's available on the farm that the conventional farmer does. And I think Cindy's exactly right. I mean, a 3-year transition period is certainly not enough to go from a conventional operation to a experienced, well-managed, healthy organic one. I think you're talking at least 10 years. And I think the whole concept of how to bring new organic farmers into business in a sustainable way it's very different than in conventional farming. I mean, with row crops, you go buy a big John Deere tractor and a planter, and you have the chemicals applied and spend the rest of the time in Mexico. It's not a terribly difficult production system, but a really well managed organic system where the farmer, the man or the woman, have been doing it for 20 or 30 years. It is a remarkable thing. And how do you get someone brought into that at that level? Because that's where it's profitable. It's not the 20 years of mistakes that you've got to make to try to build that on your own. So I think as a community, we've got to confront this whole bringing new people in. It's got to be done in a different way.
I want to turn to.
And don't forget the audience.
Absolutely. I want to turn to a topic that we've heard a lot about in the last week. We have heard a report out of the White House about the impacts of climate change. We've heard a report about glaciers melting in the Antarctic at really accelerating rates. Carbon sequestration is a pretty hot topic. Nathan, you've talked a little bit about that. What are the best practices for sequestering carbon, and are they the same? Is carbon sequestration potential similar across the country? Is there more potential depending on certain climates or site types?
It's not the same, of course. It, again, very much depends on how much rainfall, how much moisture is in a system. As far as livestock or cattle production, I should say, there's a lot of carbon in rangeland soils. The fluxes are difficult to measure, difficult to manage for, not likely to be something where we can really confidently say, if you do this to your management, it will result in this change in the flux of carbon over this period of time, and measure it and quantify it and be confident about it. The real bang for our buck in carbon sequestration in livestock production would be to let the Corn Belt revert to prairie and raise cattle on it and slaughter those cattle straight off that prairie and basically pull the corn out of meat production. In a system like that in the Midwest, more rainfall, there's enormous potential for sequestering carbon, particularly if you can stop cultivating, tilling that land all the time, particularly if you can stop putting all those fertilizers and chemicals on it all the time. That's where the real bang for the buck is. And similarly with methane, yes, cattle produce methane. But as far as being able to reduce methane emissions from range livestock production, there's not much reason to think there's some kind of silver bullet there that would have a huge effect. But management of manure in confined feedlot operations, there's a lot of potential. I'm not certain that anyone's found, again, the ticket to how to do that. But yeah, the real huge benefits for climate from livestock production have to do with reining in industrial livestock production. And there's not that much that can be done with changing how someone's running a herd of 300 cattle on 15,000 acres of semi-arid land in Arizona.
Okay, that's a good answer. And you mentioned methane, and one of the things I've read about reducing methane emissions is the importance of forage quality. And forage quality also, Cindy and Chuck, you both talked about as being important to producing healthier animals. Can you talk a little bit about, especially with methane being the top, and livestock being the top source of human-generated methane in the U.S., according to this year's EPA report, it's a hot topic, and it's an important heat-trapping pollutant to address. So can you talk a little bit about what percent of those emissions can we currently mitigate if the best practices that we know about were implemented, and what are those practices?
I'll start.
Go
Okay,
ahead.
so methane from livestock comes from two sources: enteric methane, belching, farting. Can't do so much with that, but the big area where a lot can be done is if you've got a CAFO, if you've got dairy cattle in a freestall barn on concrete, you're using water to flush that manure out into a lagoon. All of these lagoons, in confinement dairy operations and pork operations, that is the most efficient way to release methane from manure. Lagoons have the highest methane conversion factor in the EPA inventory, and so Ward and Rosie Burroughs on their dairy farms, pasture-based seasonal dairy farms, most of the urine and manure from the cows are being deposited out on the rangeland. The only manure that grass-based dairy farmers, whether they're organic or conventional, the only part of the manure that goes into a lagoon and has this high methane conversion factor is the manure from when the cows are coming through the milking parlor. And it's probably on Ward and Rosie's farms, no more than 15%. And that's kind of, unless you're going to go out and milk them, out on grass, that's as good as you can do. But there's a huge difference between methane from a lagoon and methane from either making compost out of the manure or having the animals out in pasture. So that's the low-hanging fruit in the livestock industry, is get rid of these lagoons. They're the worst way to manage manure.
Yeah, when we went into the pasture-based organic system, we mitigated 80% of our manure management, basically by going out on pasture. Our cows are always out on grass. And so that manure is, no longer a biohazard. It's now a nutrient-dense soil amendment that works quite well in our nutrient management plan. So it hits, and the way that we graze our cattle is in a managed intensive system because we are on an irrigated pasture. We start grazing in March, and because we have water, and as long as we have water, we're going to graze those cows from March all the way till October. And we do that with irrigation. And we do it under managed intensive grazing, so we're going to concentrate the cattle on a small area and then rotate them every 12 hours. So it's like a flash graze. They come in, they graze, they completely graze off. We leave about 1,500 pounds before we move on. And then those cattle do not come back to that same location for another 21, 30 days. Depends upon the growth, how hot it is. It depends on a lot of things. But ultimately, it gets a rest. It gets a month rest. And during that period of time, the grasses grow back and the roots pulse down into the soil. And we're feeding the livestock in the soil because we just fed the livestock on the soil. It worked out, quite well. So in that way, we're regenerating and the microorganisms, and it's actually the dung beetles that are also mitigating our manure management for us, because when that manure hits, the first thing that happens is dung beetles come up and then they start pulling that manure down into the soil where they feed on it, and they're actually using that for the bacteria and for the other microorganisms that are in that soil. So it's not available to produce the greenhouse gases that you would normally have in a lagoon kind of scenario. So that's the kind of thing that I think just makes this system quite nice. I mean, it's a beautiful thing.
But so let's say And one more question, then I'm going to open it up to the audience. Gun to your head, you have 25%, according to the EPA, almost 3 times as much of our methane emissions comes from enteric fermentation than comes from lagoons. And the White House's new methane strategy addressed lagoons, and that's really, really important. We've got to address these emissions, all of them. But we really got to do something about enteric methane. What's the top 2 things that we should start doing right away on our livestock operations to deal with those enteric emissions?
I must say I would dispute the premise. I don't think that is something. Enteric fermentation, I would put it pretty far down the list of priorities for climate change mitigation. Yes, methane is more potent than CO2 per molecule. It also dissipates a lot faster. There are lots of other places where a lot more can be achieved a lot more quickly and easily. And just because, well, I don't know. I don't know why you'd want to single out enteric methane as a super high priority.
I agree, and I mean, I haven't looked at the latest EPA inventory, but I'll bet manure methane is probably on par with enteric methane. And of course, the answer from the conventional industry is put the animals in the feedlot and grow them really fast, so they go to slaughter earlier. But then there's a little thing called nitrous oxide. Nitrous oxide's a lot more potent than methane, and that's, you can't produce corn in the Midwest without substantial nitrous oxide losses under a conventional system. So I agree with Nathan that I think there's a few things you can do, but I think you would do them more for the cow health benefits and the nutritional benefits than getting a return on investment in sequestering or reducing global warming emissions.
Okay. So, who has questions? Audience.
Two-part. Maybe the first is just a resource question. And I was wondering in the... Oh, great. Am I on? No.
Not
I'll just speak up. It's okay. Everyone hear me? Okay, yeah. All right, so my question is Hey, okay, now I'm on. Electrified, okay. My question is around rangeland management or with wild livestock, actually, with antelope, elk, or even bison, and whether or not anyone had done any studies on restorative practices within that. And again, I think that that's more of a resource question. I don't want to necessarily go into it. And the other was whether or not any studies have been done on water tables with restorative practices and whether or not they, just if there was effect on it.
Take that first one for sure.
Here again, there are plenty of places where people are doing things, but whether the data have been collected in any kind of systematic way, I mean, you'd want to talk to the people who manage Ted Turner's ranches for him about bison, for example. And I know he's got some good scientists, but whether that information has ever come out in the form of a publicly available peer-reviewed study, I don't know. As far as water tables, I've been to ranches and seen pictures and looked at historic records and recognized that this creek has come back to life. The water table has clearly been brought back up, and it seems to have everything to do with improving the vegetation. Frequently, it also has to do with bringing fire. This again, southwestern systems. But has it been studied and published? That particular creek, I don't think has. And again, whether you could, I mean, scientists, they need large samples to do the statistics, to come up with the significance and the, get beyond correlation to causation, that sort of thing. And how do you get that sample of enough streams over enough periods of time with, given all the variation there's going to be? I mean, how do you even start collecting your sample to start with, right? You randomly sample? Oh boy, it's, so again, it's what scientists would call anecdotes. The ones I've seen are pretty persuasive anecdotes, but studies, not quite. That's my answer, I guess. try to get you recorded.
Oh, okay. My question is directed towards Nathan. Could you explain a little bit more about why you don't consider carbon sequestration a potential tool? I know there are some studies by Ratan Lal from Ohio State who he mentioned some pretty exciting figures about carbon sequestration potential and its ancillary benefits with water storage and soil fertility and soil organic matter. So just maybe could you explain a little bit more why you don't consider that a solution?
Just to be clear, it's not that I don't think there's anything there at all, but I do think that the things that will improve the amount of carbon in the soil on these arid, semi-arid rangelands, they'll do a lot of other good things, right? Basically, good management that encourages grass cover, forage production, water infiltration, decreased erosion, all of those things will very likely result in aggregate in increased soil carbon, right? And that's great. But the cost of measuring the carbon accurately, if you were going to turn this into a mitigation strategy in which ranchers are paid for management that sequesters carbon, and you are going to tell me that a certain amount of carbon has been sequestered and the rancher's actions are responsible for it, rather than the rainfall or the weather, right? So the rancher does something and it's worth this much carbon and that's worth this much money. Actually measuring that accurately enough and being able to ensure that it's not actually just something that happened for other reasons is prohibitively expensive. Getting it down, in other words, if I'm worried about the climate, that's not something I would want to try to make work as a market or a income stream. I would much sooner go to those ranchers and say, here are a whole bunch of things you can do that will be really good for your soil and your animals and your plants, your forage, and let's make sure that your land doesn't turn into a subdivision. Let's make sure it doesn't turn into a field of crops, because that would release an enormous amount of soil carbon that otherwise is going to stay put. And let's find incentives for improving management for all these other things, because pretending that what's going to pay for it at the end of the day is some kind of scheme for carbon mitigation strikes me as foolish. Basically because we couldn't be confident that it was actually additional carbon sequestered, right? The rest of the world and its interest in reducing CO2 concentrations, they're the people who might lose from such a scheme. And there are all kinds of other reasons to manage rangelands well. And again, taking cropland and letting it go back to prairie or natural cover and ceasing to fertilize it, ceasing to cultivate it, that will increase. We know that will increase soil carbon in significant measurable ways. That could pencil out. So that's where I would focus the effort.
I was interested in the discussion you were having about the length of time it really takes to transition from conventional to organic and make it profitable. And you mentioned that 10 to 20 years of making mistakes in order to make that farm hum. And that just seems like such a huge impediment that only the most hard-headed grower would be willing to take that risk. So my question is, do you think that with greater research and especially extension that gap could be reduced, or what other kinds of things could be done to make that transition more possible, more probable?
Oh yeah, I think absolutely, because look at the number of years. We've had decades to bring on conventional agriculture, to the levels of efficiency that it's at. And so if we had that same amount of money that has been put into organic agriculture, I think we could make huge strides. But currently, the way that the funding is currently set up in USDA, there's just a minimal amount that's really dedicated to organic research. The lion's share, of course, is really going to a whole host of other types of research. But the fact that we focus so little on organic, it's almost like, it's just a token amount. It's a very small amount of money that's going that direction, particularly considering how, concerned we are, as a society about greenhouse gases and about food and our food system and the impacts that, our food system has had on our rural communities. I mean, these are big concerns that people have. If you were to, that it just surprises me that we spend so little on that kind of support system. We don't have enough money going towards that direction. We don't have enough extension agents really trained in that particular area. We don't provide enough support for those farmers. It's not in the Farm Bill. We have some conservation practices there currently, which is really good. EQIP is now, embellished. We're seeing more funding going that direction, but it's not near enough.
I would just add that, I've been studying the performance and economic viability of both conventional and organic farms for my whole life, and I've farmed a bit myself. And one of the things that we have to remind ourselves of both the conventional side and organic side is that there's a huge difference between the most experienced, well-managed farms and other farms. And I mean, if you look at the USDA data, they're corn. You can have a $2 difference in the cash cost of producing corn between the best operators and the least experienced and capable operators. This problem of gaining the experience and the opportunity to manage a farm where most of the assets are paid for, I think it is impossible for a young couple without family resources in one generation to go to a commercial scale organic farm, with the possible exception of wheat or row crops. But in vegetables, I think it's impossible. And now there's probably a few people that can do it that are just incredibly smart and lucky. But it takes so much knowledge about the system and just how to be a good farmer and facilities. I mean, Will Harris the success of his operation, so much of it was from the processing and marketing side. Without that, the farm wouldn't go. And so I think we have to really step back and rethink about how people are brought into these operations. These wonderful operations, they're out there. We've got to figure out a way to get people into them and spread them. But to think we're going to take people, get them their first rototiller, and have them in one lifetime build those kinds of operations, we'll grow pretty slow if that's the model.
Thank you. Good answers. We got time for one or two more. Doug.
Hi. Hello? Okay.
You're good. You're live.
Doug Sims from NRDC. First of all, thanks so much for coming. It's been an amazing discussion. And our group that we work with is based on market transformation, using the market to drive deep-seated changes in the whole economy, including the food economy. And so we looked at some of these issues for a few years now, and Nathan, we agree with you that the carbon markets are not going to work to drive this change. So our working theory now, that's going to be the actual the meat market or the dairy market that will be able to drive this change. And we're seeing some bold pronouncements by a lot of big players like McDonald's. McDonald's has said it's going to start procuring sustainable beef in part by 2016. But figuring out what that means is a big question, and not being greenwashed so I guess my question is, if you were going to tell McDonald's what are 3 things that it should look for in the supply chain and demand over a period of, say, 10 years, what would those things be?
Get rid of the generalized antibiotic use. And I say that not because it's going to help rangelands, but because it's just insane. It's completely insane. If McDonald's tells the world's beef producers they can't use antibiotics as a routine prophylactic thing,
Subtherapeutic.
they'll stop. And that would be an incredible benefit to all of us. So that's the one I would put on the top of the list.
That was exactly where I was going to go. Okay. Yeah, the number 2 would be no use of any anabolic steroids in the use of growth-promoting technology. So no implants, no growth hormones, 0.
Of which essentially all conventional beef probably has 2 or 3 doses of growth hormones early on and then a beta agonist towards the end of the time in the feedlot.
And ionophores thereafter, right.
And so the third, cut by half the pounds of gain put on in the feedlot and get it back on grass. So you got 600 pounds being put on in the feedlot on average, in the average steer. Get that down to 300 pounds, still be acceptable quality. And that shift, I mean, that, Nathan, you take 300 pounds across the entire U.S. beef herd, you're going to sequester a hell of a lot more carbon, and there is going to be a lot more forages.
And be sure you have a meeting very early on with the senators from Iowa and Illinois.
Should be very interesting.
All right. Well, okay, one more.
Professor Benbrook, you mentioned that many of the epidemic health problems we have are perhaps a reflection of the poor nutrient quality of the food. So one thing that's being discussed in a lot of different parts of the environmental community and others is meat consumption and its effect on health and on climate. So if we were to have better meat, how does that interact with the level of consumption question? Do we need to reduce consumption and increase quality, and which one is more impactful on human health, the quantity or the quality or the quantity?
I mean, how ridiculous is it to go to a restaurant and have a 16-ounce porterhouse steak? I mean, come on. Most of the world gets by with 3 or 4 ounces of meat in a serving. I mean, I love meat. I eat a lot of meat, and I've had my share of 14-ounce steaks. But, I think we do need to go back to smaller servings and appreciate quality meat. I mean, some of the pork that I've had, some of the heritage pork where they're out on grass, and the improvement in flavor in pork is even greater, in my opinion, than in beef. It's like, oh my God, it is so good. And it's going to be more expensive, and that means people will eat less of it, but that'll also mean people will be healthier. So, I'm all for higher quality and less consumption.
All right, and with that, we're out of time. It's been an amazing panel that's gone by really quickly. We've learned that organic and grass-fed, these solutions that are better for the health of us as people, are also in many cases better for the health of ecosystems and for the health of the animals. But we've also learned that there are questions that are unanswered, such as how does grazing management itself, whether a ranch is well managed or overgrazed, affect the health of the meat? And we've heard about barriers to implementation from the policy side to the lack of technical assistance. So we have some work to do there as well, and we've heard about how companies like McDonald's, if they take action, they can drive significant change. And I think that not only applies to McDonald's, but really across the buyer supply chain. Anybody from Chipotle to In-N-Out Burger who serves antibiotic-free meat, all across the spectrum. And you all can help drive those changes by making those choices and asking for them. So good work, everybody. Thank you so much for an excellent panel.